this video, we're going to look at special angles. What are they and how do we use them in our right angle triangles? When calculating sine, cos and tan, most of our angles are long decimals and we have to use the calculator. But there's three special angles where we don't need to use the calculator. They are 30 degrees, 45 degrees and 60 degrees. Well, where do these come from? Let me show you. Two triangles I've got here. One is an equilateral triangle of side length 2. Remember, an equilateral triangle will have all angles 60 degrees. The second triangle is a right-angled isosceles triangle, and I'm going to give my sides 1 and 1. Now, before I do anything, I want to find the perpendicular height of my equilateral triangle, and I want to find the hypotenuse of my isosceles right-angled triangle. So, applying Pythagoras' theorem to both of them, we know that the perpendicular height is going to turn out to be root 3, and we know the hypotenuse on my right-angle isosceles will be root 2. Now, it's really important to get those correct because these two triangles, together with the three sides and the angles, are going to give me all my exact values. There are 9 exact values in total. Let's start by doing the 30-degree ones. In this triangle, we'll look at sine 30. Remember, sine 30, sine is equal to opposite over hypotenuse. So just following the rule on my triangle, I'm going to get sine 30 equals 1 over 2. That's it, sine 30 equals a half. What about cos 30? Well, cos 30 is going to equal root 3 over 2. And of course, tan 30, following opposite over adjacent, I get 1 over root 3. They're my 3 exact values for 30 degrees. While we're in this triangle, why don't we do 60 degrees? So let's have a look at sine 60. Well, sine 60 equals root 3 over 2. Cos 60, following my rule, adjacent over hypotenuse is going to give me 1 over 2. Cos 60 equals a half. And tan 60 gives me, that's right, root 3 over 1, which we can just write as root 3. Now let's go to the second triangle, because this triangle gives me my 45-degree angles. Once again, sine 45. We know sine is opposite over hypotenuse, 1 over root 2. Well, let's do cos 45. This is interesting. It's still 1 over root 2. And finally, tan 45. Look at this, tan 45, 1 over 1, which is 1. That's it, our 9 exact ratios. Sine 30, cos 30, tan 30, sine 60, cos 60, tan 60, and finally sine 45, cos 45, tan 45. How do you get them? You need to remember them or you just learn your triangles. Let's see now how we actually use these in right angle triangle examples. Why don't we have a look at a couple of examples where we use these exact ratios. This first example is a right angle triangle. I've got an angle of 30 degrees, a height of x, and my hypotenuse is 7. We've done this before. Right angle triangles, label our triangle, what trig ratio am I using, and apply it. Well, this is obviously sine. I've got the opposite and I've got the hypotenuse. So I'm going to set my equation up. Sine 30 equals x over 7. To solve this, we multiply both sides by 7. So we're going to calculate x equals 7 sine 30, but we don't need a calculator. That's right, 30 is an exact value, and if you remember, sine 30 is equal to a half. So all we have to work out is x equals 7 times a half, meaning a half of 7, which is 3.5. Okay, what about the second example? This time, I've got an angle of 45 degrees, a height of x, and we'll give my hypotenuse a value of 5. Well, this time it's not a sine. It doesn't look like a tan because I don't have the opposite. It's definitely a cos. So we'll set up cos 45 equals x over 5. Once again, my unknown is on top, so we need to multiply both sides of this equation by 5. I end up with 5 times cos 45 equals x. But you know cos 45 is an exact value. So that exact value comes from my isosceles right angle triangle. Cos 45, remember? That's right, 1 over root 2. So 5 times 1 over root 2 is just 5 over root 2. So the value of x is 5 over root 2. That's an exact value. You can calculate it, but you don't need to. You can just leave your answer as 5 over root 2. That's it. Exact values, 30 degrees, 45 degrees, 60 degrees, can be found in right angle triangles without the use of a calculator. I hope this has been helpful. If so, don't forget to click on the link in the description, subscribe, and we've got some examples and a worksheet waiting for you.